Hello students, welcome to the EN 401 lecture on centroids. This is Lieutenant Puckett. I'll be taking you through this one. Alright, so today's lecture we're going to talk about centroids, which is another name for center of area and center of gravity. Alright, so we've got this great picture here, and it's depicting how one method to find the centroid of an object. Essentially, we can draw some bisecting lines, and where those bisecting lines intersect, we can call that the center of area or the centroid. So this is sort of one graphical way to do it, but this isn't necessarily the most practical way, since this requires a very precise drawing to get to this, and a lot of times we deal with sketches. So with our sketches, we'll need to use a mathematical method to find the centroid, or the center of gravity. All right, so the center of area, or the centroid, is the location of the geometric center of an object, and when we calculate where that is, it's going to be in reference to our reference point. So with respect to the reference point that we choose. All right. The center of gravity is essentially the balance point of your object based on weight distribution. And again, when we find that point, it's going to be with respect to our chosen reference point. So for both of these methods, we're going to use a weighted average method, which I'm sure you've used before, whether it's in calculating your Cooper or something else. And using a weighted average method with respect, again, to that reference point. So that's repeated multiple times in here because that's probably one of the most important steps in this process, is picking a reference point and sticking to it. And again, both methods require us to pick a reference point. Again, more emphasis on a reference point. I think that's probably the biggest error that we see in both of these calculations, is a reference point isn't chosen, and then things move, and then we get values that don't make any sense. So let's take a look at what that looks like. So we've got this composite object here. Not really very easy to figure out where the center of area or center of gravity is. Let's assume that the gray rectangle and the blue rectangle, they're attached, but maybe they have different weights. They're different materials. Maybe one is steel and one's aluminum, right? So they our center of gravity and our center of area won't be the same in this particular little example. But again, what we have to do is we have to pick a reference point, right? Then we can do our weighted average calculation, and that'll tell us the center of area. So it's irrespective of the weight of these things, is about there. And then because, you know, the blue rectangle and the gray rectangle aren't the same weights, right? Maybe our center of gravity is a little bit different than our center of area. All right, so we'll walk you through the process on how to calculate both of those. All right, so to calculate the center of area, we are going to find that center of area, and we're going to be doing 2D problems, so we just need to find the x and y coordinate of that center of area, and we'll use these weighted average equations. So center of area, or centroid, if we're trying to find the x center of area, we're going to call that x bar. So x bar is going to equal to the sum from 1 to n. So that's just if you have a composite shape made up of several shapes, like 3 or 4 shapes, right? You're going to have to find the sum of all those shapes. And it's going to be the sum of xi times ai. So xi is the distance from the reference point along the x-axis to the centroid of our individual shape. All right, you'll see what that looks like, you know, in the upcoming slides, right? So big thing is it's distance from the reference point along the x-axis. So really it's going to be distance from the y-axis but it's distance along the x-axis to the centroid of each individual shape. So we have, in that previous example, we had two rectangles, so we'd have x1 and x2. Then we're going to multiply that times the area of those individual shapes. So that previous example, again, we'd have two areas, so A1 and A2. So we do x1 times A1 plus x2 times A2. And we'll add those together, and they'll divide that by the sums of the area. So we'll just add up all of the total area of our composite shape, and we'll divide. And if we look at how things shake out with units, right, essentially you'll have area canceling, and you'd be left with just a distance, right? Go ahead and erase those. All right, so the process for finding the y centroid is the same, except we're going to be measuring distances along the y-axis or from the x-axis. So same formula, sum of yi times ai divided by the sum of ai, or the total area. All right, so in order to find the centroids of those individual shapes, we're still going to need to know where they are for some common shapes. So we've got this chart here on the right, and we have a bunch of common shapes in there. So rectangles, triangles, circles, and we got a half circle there. So we've got a reference point, and this little chart here is going to tell you the area of each shape and the location of the x and y, or the value of the x and y coordinates with respect to these reference points to the centroid. So, rectangles are pretty easy. Our x distance from a reference point to the centroid is just the half of the base, so b over 2. And, for our y centroid distance, it's just going to be h over 2. So things get a little trickier with our triangles. So if our reference point is in the bottom left of that right triangle there, then the distance from our centroid to this x center of gravity, or excuse me, x center of area is actually going to be 1/3 of the base. So it's going to be b over 3. We actually have the same condition going the y direction. The distance from our reference point to the center of area in the y direction is h over 3, right? So that's from that right angle. It's 1/3 of the base to the x and 1/3 of the height to the y. So if your reference point was maybe up here at the top, which I'm trying to draw that for you there. So let's say this was your reference point. Then your y bar distance would then be this larger distance, right? So this would be 2h over 3. But your x distance would still be b over 3. So triangles can get a little tricky, so just make sure you take a good look at what's going on, and make sure you pick the right distance, either 1/3 of the base, or 1/3 of the height, or 2/3, just based on the orientation of the triangle. Well, we've got our circle, so our reference point is here, so that's coplanar with the bottom and the edge of our circle, right? So our x bar distance is just going to be the radius, and our y bar distance also the radius, right? Our radius is half the diameter, so that's would be the radius, that distance there, and the diameter would be just this whole distance, right? And then for our semicircle, here's the area, and our x distance is still just the radius, right? Still the distance is still the radius there, but our y distance becomes the shorter distance, which is 4 times the radius divided by 3 pi. Right, so you'll probably reference this a couple times unless you already know all these. So make sure you know these. But these are integral in the 7-step process we have over here for finding the center of area. So step 1 is we're going to break our composite area up into smaller, simple shapes, right? So we'll try to choose from these shapes on the right and break up our composite area into a bunch of those simple shapes. Step 2, pick your reference point. So possibly the most important step, pick the reference point, right? If you don't have a solid reference point, you move the reference point around, you'll get a nonsensical answer that doesn't make any sense. Step 3, so you've got the shapes broken up, you've got your reference point, then what you're going to do is you're going to sketch the approximate location of the centroid of each smaller simple shape, right? So you just put a little X or something where you kind of visualize the centroid of each individual shape to be. And you can use this chart on the right to help you in those sketches. Then step 4, you're going to do some simple calculations to find the distance from the reference point to the centroid of each shape in both the X and Y direction. Right? So again, this chart on the right here shows you the distance to the X and Y center of area from the reference points that are listed for each shape, but your reference point for a composite shape may not necessarily be, right here, like for this rectangle. It may not be right there. Your reference point could actually be, maybe over here in this area over here. So then if you needed to find that X bar distance, it would be this total distance. So you'd have to do that simple calculation to find that. Let me erase some of these extra lines here. All right, so once you have all those distances, then you'll calculate the area of the shape. So step 5, calculate the area of each shape. And then step 6, you're going to calculate the location of the centroid of the composite shape, and you'll use the formulas from the previous slide to find those centroids. And then once you have found the centroid of the whole shape, you'll sketch that on the composite shape and sanity check the answer to make sure that what you calculated actually makes sense. All right, so that's a lot of steps. And it can be pretty complicated, so the next slide is going to show you a simpler way to kind of make this easy. All right, so the easy way to do our centroid calculation is to use a table and to just plug into the table. So, you'll break your composite shape up into several different shapes, right? And then you'll put those shapes here, so you'll have to give each shape a label. So, if we reference back to that first quick example problem we saw, we had 2 rectangles. That could be shape 1 and shape 2. But if you had more shapes, you just keep adding, more boxes. Right? Then you pick your reference point, and then once you pick your reference point, you can do some simple calculations to find the distance from the reference point to the centroid of each individual shape, and then you just pop those in the boxes here. Then you calculate the area of each shape. And then you can populate this xi times ai box. So you would just multiply this value times that value, and that gives you that. And then if you wanted to do your yi times ai, it would be that one times that one to give you that one. So you do that across all the rows. And then we're going to calculate the value for box 1 here. Right, so we're just going to add up that box and that one, and that will give you this value. We're going to calculate box 2, so we'll add this one and that box, and that will give you the value for box 2. And the same thing for box 3. We're going to add that one and that one, so add up all the areas. You're going to get this value. All right, so once we have those 3 values, we can find the centroid of our total shape. So to find our X bar, we just divide box 1 by box 3, right? So that's this equation here. Sum of xi times ai, that's box 1, divided by the sum of a, that's box 3, and then I'll give you the X bar coordinate. And then again, it's with respect to your reference point. So if you move your reference point, this number will be nonsensical, right? Because these will change. The whole thing will be kind of way off. All right, so same process to find y bar. We'll just divide box 2 by box 3, and that will give you y bar. So the common mistake I see is people will just add xi from shape 1 to xi to shape 2 and say that's x bar. So that is not a proper calculation. If it was that easy, then we wouldn't even need the table, right? So we need to fill out these boxes on the far right here, and then you do the division to find x bar and y bar. So don't just add up xi's and yi's. That will give you an answer that doesn't make any sense. And if you plot that answer, you'll see you'll probably end up off of the shape, and then it really doesn't make any sense. All right, so we have a Centroid example here, and so go ahead and pause the video and try to work this solution out on your own. But before you start, ask yourself these 4 questions. Question 1, where should you place the reference point? So far we've seen a lot of reference points being placed here, and sometimes it's good just to have the repeatability of just placing the reference point in the bottom left. But you don't have to put it there. You could put the reference point, over here if you want, or you could put it up here if you want. I mean, you could put it anywhere as long as you pick one point and you don't move it throughout the entire process. Question 2, how many shapes should you break this up into? 1 or 2 or 3 or 4? That's up to you. 3, make your table, help you keep the process smooth and clear. And then 4, go ahead and go through that 7-step process and find the centroid with respect to the point you picked for your reference point. So go ahead and pause the video and do this example, and then there's also a solution video that you'll find to go along with this. All right, so now we're going to move on to center of gravity. So center of gravity utilizes a very similar weighted average equation as center of area, except we're just replacing the area of the object to the weight of the object. So xi and yi in this equation remain the same. So that's going to be the distance from our reference point along the x or y axis to the center of gravity of each individual shape. And then wi is just the weight of the individual shape. And then x bar and y bar, that is going to be the distance from the reference point to the center of gravity in either the x or y direction of the whole composite shape. So of note here, so center of gravity of each shape is located at the centroid of each individual shape, right? So if you have, a rectangular piece of steel and it's got a weight of 10 pounds, then the center of gravity that rectangle is going to be also at the center of area. All right, so center of gravity steps are very similar. Again, you can use this common shape chart here to the right. Center of gravity has one less step than the center of area, but essentially the same process. First, you're going to break the composite mass into smaller, simple masses or shapes, and then you're going to label each one of those. Step 2, very important step, pick your reference point and define your axes. It says choose wisely, right? Because you could potentially choose a reference point that cancels some things out in your calculations. You might see that in some of the example videos. But it's very important you pick a reference point and you don't move that reference point. All right, step 3, sketch the approximate location of the center of gravity or centroid of each smaller simple shape. Right, so for like a rectangle, the location of the center of gravity and the center of area are the same point, at least for this class. All right, then step 4, go ahead and calculate those xi and yi distances from the reference point. Be sure to use the reference point to get those distances and not to move that reference point around. Step 5, calculate the location of the center of gravity, so your x bar and your y bar values using that weighted average equation. And then once you've calculated the center of gravity, go ahead and sketch that on your shape and make sure that it makes sense, right? If you get a center of gravity that's way off, then maybe you did something and you need to go back and double check your answer. So just like with our centroid calculation, center of gravity, we can use the table. We could actually even merge this table with our center of area if we needed to. If the question was asking us both of those things, we could just add an extra column for W. But if the question is just asking you for center of gravity, we just use this table. So everything is the same as center of area, except we've replaced area with weight, right? So all of our A's have changed to W's. So you just fill in the table, you find each one of these values, then you plug in the weight, and then you multiply those together to fill in these boxes. And then once you have those boxes filled in, you'll add this box and this box to get value for box 1. You'll add these up to get the value of box 2. And then you'll add these up to get the value of box 3. And then with those values, you can calculate x bar and y bar. Remember, you cannot just add these values up and say those are equal to y bar or x bar. That doesn't work, right? If you could do that, then there would be no need for this these right 3 boxes. And again, if you go ahead and sketch that center of gravity on, if you just added those up, you'd see that you'd get an answer that doesn't really make sense. So make sure you do your weighted averages by dividing the boxes of 1, 2, and 3 appropriately to get your x bar and your y bar equation or answers. All right, so we've got another center of gravity example here. So same shape as we had in the previous example, and you should have found that centroid by now. So now we're going to put some weights to that object, and we're going to go ahead and calculate the center of gravity. So we have our rectangular object has a weight of 10 pounds, and our triangular object has a weight of 20 pounds. Right, and now we need to find the center of gravity. So you can go ahead and pause the video here and do that calculation. Before you do that, you ask yourself these 4 questions. Where should you put the reference point? I mean, you could use the same reference point as the center of area, or maybe you learned something from the center of area and you're going to choose a different reference point. That might make your calculation simpler. Are the centroid and center of gravity going to be at the same location? What do you think? I don't know. Third question, make your table, keep the process clear, and 4, make sure you go through all 6 steps, right? Don't skip any steps. Make sure you draw all those centroids out, centers of gravities out, and make sure you sketch it at the end to make sure your answer makes sense. So go ahead and pause the video, do the solution, and there is a solution video for you to watch also. All right, so a quick review. So for a 2D object with evenly distributed weight, what is unique about the center of area or the centroid and the center of gravity? They're co-located, right? So if we have a 2D object and everything's evenly distributed, our center of area and center of gravity will be at the same location. All right, so always sanity check your work. Draw that, do that last step, draw the coordinates that you got onto your shape and make sure that they make sense. Big thing, if you have several objects and things start to get difficult to manage, draw the table and keep your thoughts organized. Remember that don't just add up your xi's and your yi's on the table. You've got to do the weighted average to get your x bar and your y bar. And then this last point, so the most common error is jumping that reference point around. So make sure you draw that reference point, sketch your centroids of each individual shape, and then find the distance from the reference point along the X or Y axis to that individual shape. Don't move that reference point around. So if you have any questions, feel free to reach out to your instructor, and I hope you enjoyed the lesson.